All right, we're looking at number 6. Number 6 says an antelope moving with a constant acceleration covers the distance between 2 points 70 meters apart in 6 seconds. Its speed as it passes the second point is 15 meters per second. What are A, its speed at the first point, and B, its acceleration? So let's draw us a little diagram here. We're talking about 2 points, and we know they're 70 meters apart. So we're going to talk about the motion between these 2 points. So we're going to call that our delta x. And we know our delta x is 70 meters. So what else do we know? We know the motion takes place in 6 seconds. So t equals 6 seconds. We also know when it passes the second point, so let's say this is the second point, is 15 meters per second. So we're going to call that our final velocity and our initial velocity of the motion. So we're talking about a motion that takes place in 6 seconds. We're not at rest here. We're just looking at this 6 seconds, the 70 meters. So we know this final velocity is 15 meters per second. So that leaves us with, we need to find the initial velocity in meters per second and our acceleration meters per second squared. Alright, so let's look at part A. So part A, we've got 3 pieces of information. We're talking about a constant acceleration, so we know our kinematic equations apply. So we have displacement, we have time, and we have final velocity. So we don't know any information about the acceleration, but we can find our initial velocity. So if we look at equation number 3, so delta x is 1/2 v naught plus vf times t. So we need to isolate v naught here, so get rid of the terms that are multiplied. So we can say 2 delta x divided by t equals v naught plus vf. So then we need to get rid of this term. We subtract it. So we get, I'm going to put v naught over here, is 2 delta x, my hand's going crooked, divided by t minus vf. Alright, if we plug the numbers in, 2 times 70 meters, close the parentheses, 6 seconds minus 15 meters per second. So that gets us an initial velocity of this 6-second motion of 8.33 meters per second. Alright, this is the second part. Second part is acceleration. Well, now we have 4 out of the 5 variables, so we can use pretty much anything we want. So we're going to look for acceleration. And the easiest one, I always go with the easier one to solve, whichever one's easier to do the algebra with. So we're going to do A is VF, minus V initial divided by our time. So now we have both this bit of information, so we have 15 meters per second minus our 8.33 meters per second, all divided by our 6 seconds. So that gives us an acceleration of 1.11 meters per second squared. Alright, so that's how you do that one.